Hello and welcome to TrainSignal. You are watching Linux Databases. When I first started learning about databases, the analogy someone shared with me was this. Think of a database as an expandable electronic file cabinet. Perhaps that is a rudimentary comparison, but it did the trick for me. At the heart of GlobalMantics and every company across the globe is its data. That data comes in many forms, and a common storage mechanism for data is a database. To interact with this data, you use a programming or scripting language like SQL. Now, if you stop for a moment and think about your own organization, you can probably come up with several categories of data that are probably currently stored in a database. Things like employee information, customer information, and if your company produces a product, you'd probably want to store product information. And there are probably dozens more examples, but hopefully the picture is forming for you. So in this lesson, we'll cover the SQL language and Oracle's SQL implementation, MySQL. We'll talk about the concepts of a database and tables. Then we'll get into the nuts and bolts, how to manage the data, storing, retrieving, and deleting. Let's get started with an overview of SQL. Remember we talked about the different pronunciations of commands and programs in Linux? Well, SQL is a good example of that. Most in the community will probably refer to it as SQL, and that's how we'll refer to it from this point on. So then your first question probably is, what is SQL? Well, it's a language, but one specifically used to interact with a database. Its commands allow you to store, retrieve, delete, and otherwise manage the information that you store in a database. Now there are several different SQL packages, of which MySQL is just one. Other popular options include Postgres and SQLite. MySQL is very popular and is included in most Linux distributions. If the package isn't installed on your system, on RPM systems like Fedora, you can install it with the yum command that we learned in the package management lesson. The command is yum install MySQL space MySQL-server. This will install both the client and the server program. Networking pros should be familiar with the client-server model. In this case, the server manages the database, while the client portion gives users and programs access to the database. You can then start MySQL with the command etc init.d mysqld space start. Now remember that initd is a startup script. For a test system, this may be enough, but if you want to make sure your installation is more secure, run the MySQL _secure _installation command and follow the prompts. You'll probably also want to set up a password for the root user for MySQL, and you do so with the MySQL admin space -u space root space password command, where password is the password that you want to set. Now again, in addition to MySQL, there are several other products or packages. PostgreSQL is a derivative of the Ingres software. Then there's also SQLite, which is a library, not a database, so its purpose is to allow programs to store data using a SQL interface from within the program. And just so you know, MySQL is the package that is referenced for the Linux Plus certification. So that's the one we'll cover here. But as time goes on, you may find that you prefer one of the others. I have friends that swear by Postgres, for example. Let's continue our SQL overview on the next slide with a look at relational databases. A database most often contains one or more tables, and each table has a name, like customers or products. A relational database stores data in a table with rows for items and columns for attributes. So tables contain rows, also known as tuples, and columns are also known as attributes or fields. Databases are most useful when it comes to storing information that fits into logical categories. For example, say that you wanted to store information on all the employees in a company. With a database, you can group different parts of your business into separate tables to help store your information logically. Take the example table on the screen that I call transportation. It contains 4 records. The first column represents the mode of transportation, and we have car, motorcycle, moped, and bicycle. The second column is for color, while the third is for manufacturer. So the first row contains a record for a car that is blue and is made by Toyota. Now this is a very simple example just to illustrate the basic concept. We'll build another table shortly. Now the data in this table consists entirely of regular characters, but in the real world, this won't often be the case. More likely, you'll have a combination of numbers, characters, dates, and even more. Let's take a look at some of the most common data types on the next slide. Again, our first sample table held only characters, but on the next two slides, we'll take a look at other data types that you may use in your databases. The first is integer, which is shortened as int. Integer stores a whole number, 4 bytes long, and small int, the next data type, stores a whole number, but it's 2 bytes long. Decimal is a fixed storage data type with decimal values. Decimal is one you'll probably find yourself using often. The next is numeric, and that's for fixed storage of decimal values. Float represents a rounded floating point number. Double precision is a floating point number stored with twice the precision of float. Float and precision could be useful for storing data when memory is an issue, but I personally haven't found much of a need to use either. But your experience may be different. Some in the community feel that float and even double precision have difficulties with rounding numbers properly. Continuing our look at SQL data types, the next is datetime. And datetime stores date and time information in the format 4 fields for year, 2 for month, 2 for date, followed by 2 for hour, 2 for minute, and 2 for second. This could be useful for, say, shipping or receiving information. The next is date, which is a shortened form of datetime, and it just includes the date information in the same format, 4 for year, 2 for month, and 2 for day. The next is time, which shows the time in the same format for date time, and that could be either for time of day or a period of time. The next is car, which stores 1 or more characters. And then you have varchar, which stores a variable number of characters or strings. This can hold between 1 and 255 characters. Varchar is usually the wiser choice over car, due to its variable length format. Although keep in mind that car is much faster than varchar, sometimes up to 50%, so I hear. Enum can contain a list, like small, medium, or large, and the last is set, which is a data type of string that allows one to choose from a designated set of values, be it one value or several. You might use this data type to select car add-ons, like a sunroof, airbags, or leather seats. Now that we understand data types, let's move on and talk about how to build our own databases and tables. To launch MySQL, simply type in MySQL space -u space root space -p at the command prompt. This will prompt you for the root password for MySQL. Your regular Linux prompt will be replaced by the words MySQL and a greater than sign, and you enter commands from this prompt. In order to obtain help at any time, you can type in /help. Since, like me, you probably just installed MySQL on your test system, you probably won't have many databases installed. But to verify this, you type in the command show databases followed by the semicolon. Depending on your distribution, you may have a database called test. One thing to note is that you'll often see MySQL commands in all uppercase, but this isn't required, as the program isn't case sensitive. My guess is that professional database administrators might be sticklers for this, but we won't worry about that. Also, each command must be terminated by a semicolon. So, wondering how to create a database? It's really quite simple. You just type in create database followed by the new database name, and you end that with a semicolon. If you forget to end it with a semicolon, you can hit enter. On the next prompt, you type in the semicolon there. Now, to begin populating your database with tables, you must first use it, and you do that by typing in use followed by the database name. Like show databases, show table will display any existing tables, and describe table name will show you the fields. And to create a table, you type in create space table followed by the table name and of course your semicolon. For Global Mantics, Example tables might be employees, supervisors, and customers. Each table would then contain columns specific to these three areas. To help store information related to each employee, the employees table might have the following columns: hire date, position, age, and salary. John Smith, which would pull John Smith's salary. Or you could try select space salary from employees, which will get you a list of all salaries from the table. Select name and salary would get you both, of course, the name and the salary. And you could use an operator like greater than, like select salary from employees where salary is greater than 70K. Now in all but the most rare circumstances, you'll have more than one database and probably more than one table. For GlobalMantics, we could theoretically have an employee table, a products table, an applications table, and countless others. Now there may be times when you need to combine two tables so that you can extract information from both of them. For this to happen, both tables will need to have one unique field that identifies each row. That field is called the primary key. For our employees table, the name could serve as the primary key, or if each employee had an ID number, that field might work even better. So, how do you create this new combined table? First, let's switch back over to our terminal window, and then we'll create a new table. Okay, first let's start by creating a new table, and we'll call it products. So type in create space table space products. And for our fields, we're going to have name, which again will be a varchar, 30 characters in length. Then we're going to have an ID field, which will just be an integer. Then we'll have a developer field, which will be a varchar of also 30. Close the parentheses and add the semicolon. Well, let's check our syntax. We have create table products. The first field is name, which will be of type varchar and 30 characters in length. We have an ID field, which will be an integer, and we have a developer field, which will be a varchar of length 30 again. So let's hit enter. Okay, now let's type in show tables to make sure that it's there. And we see that we now have two tables. Now let's take a look at the fields for products with the describe command. Hit enter. And we have our field names again. We have name, which is a varchar of 30, ID, which is an integer, and developer, again a varchar. Okay, so now let's populate our table. For that, we're going to use the insert into command, products, and we're going to add the values. For the name, for first product, let's just call it accounting since it's an accounting software. The ID will be 1 since it's our first product. And the developer will be Jane Doe. Close parentheses. Let's check our syntax. We've got insert into products with the values accounting, the ID of 1, and the developer Jane Doe. Now let's hit enter. And we see that that completed okay. Now to combine the two tables, we can use either the select or the join statements. Let's try select first. To use the select statement, we're going to type in select space employees dot name, comma employees dot hire date, comma products dot developer from employees and products. And we see here what we returned is the name of the employee and the hire date along with the developer that we selected. Now if you want to use the join statement, you just type in, I'm going to use the up arrow to save us some typing space here. We want select employees.name, employees.hire date, products.developer from employees, and then we're going to take out the comma here and just type in join products and hit enter. And again, we see that we have the same data that was displayed. Okay, let's go back to the presentation and talk about removing data. As it turns out, some Global Mantic's Windows administrators don't like the idea of moving to a Linux shop and have decided to take their talents elsewhere. So how do we update our employees' database and remove them? We do so using the delete command. The syntax is delete from table name where followed by conditions. As a note of caution, you should probably use the select command beforehand just to make sure you're not accidentally picking up the wrong records. Now, during my own testing, I've mangled databases and tables to the point where I felt like it was just best to start all over again. If you want to delete all the info from a table, use the command delete space asterisk space from space table name. Now that just removes the data and not the table. If you want to delete the table, you use the drop command, which is drop space table followed by the table name. Okay, let's head to our terminal window and try this out. Okay, let's start out by typing in select space star or asterisk from products and hit enter. And we can see that we have one record in this table. Okay, say that we wanted to delete that one record. We would type in delete space from products, which is the name of our table, where followed by the condition, and I'm going to say where name is equal to accounting. And let's follow that with the semicolon and hit enter. Now let's use our up arrow to take a look at the products table again, and we see that we have an empty set. So what if we want to remove the products table altogether? If you recall, we do that with the command drop table. So let's type in drop space table followed by products, name of our table, and hit enter. Now let's type in describe space products, and we should get an error telling us that it doesn't exist. Hit enter, and we did. We have an error here that says that products no longer exist. Now, I'm no database administrator, but I have tremendous respect for these folks, and I can tell you that what we've covered will provide you the essential information you need to start building your own databases, and certainly to prepare you for the Linux Plus exam. But this topic stretches well beyond this information. And that concludes our lesson on Linux databases. Let's review what we've learned on the next slide. Databases are at the core of most enterprises. So even though they may not be your primary responsibility, Linux administrators still need to have a good understanding of databases, the language used to manipulate them, and how to accurately retrieve information. In this lesson, we learned that SQL is a structured query language that lets you access and manipulate databases. We learned that relational databases store information in tables, and that through MySQL or MySQL, you can store, retrieve, and delete data. Thanks for watching, and I'll see you in the next lesson.